Hi everyone, we are going to solve the integer solutions for this equation x square plus x equals 9120. So how would we solve this equation? So first what we can do is we can factorize. As soon as we see a quadratic equation, what can we do is factorization. So let's bring all the terms on one side. So that will be equal to x squared plus x minus 9120 equals to 0. Now what's the next step? What you can do is the product should be 9120 and your sum should be plus 1. The coefficient of x is 1 and the product should be 9120. So it is always in a form of factors. This is the method 1 which we are talking about. I'm going to show you the second method as well for this, which is very wonderful. Now for this method, your factors has to be in the form of x plus, as this is minus 9120, you'll have x plus a times you'll have x minus b equals 0. Now what you can do is you can expand these two. That will be x into x squared plus you will have ax minus bx minus ab equals 0. Now if you can club this, you will have x squared plus a minus b into x minus ab equals 0. Now what you can do is you can compare these two equations, this one and this one. So here you have coefficient of x squared as 1, coefficient of x is a minus b is 1, and ab is equal to 9120. So you have two cases what you're getting here. So let me write down the two cases what you have here. The first case is a minus b equals 1, and the second case is AB equals 9120. Alright, so the first one is a minus b equals to 1. Now what we can do is let's solve for AB equals to 9120 as it is a product. So what we can get from that is, let this be, I'm going to write that, let's see what is the range. It lies in between two perfect squares. So if I say 8100 is a perfect square, and I can also have 10,000 as a perfect square. So 8100 is 90 squared and 9120, and 10,000 is 100 squared. So that's how it can lie between 90 squared and 100, 90 and 100. So we have to find two numbers between 90 and 100. When we subtract, it gives 1, and their last digit of the product should be 0, as AB, the last digit of the product is 0. So if you subtract those two numbers, you should get 1, and the last digit of the product is 0. So you can have 4 cases for that. Let's see what are the four cases. So you can have 90 and 91, because when you multiply the product will be, the last digit of the product will be 0. Yes, and if you cannot have 91 times 92, because when you multiply, the last digit won't be 0. Not even 92 times 93, no. 93 times 94, no. Yeah, but you can have 94 times 95, because when you multiply 5 times 4, it's 20, and 20 has a last digit of 0 as this. So you can have this. Then another option what you can have is 95 times 96 as well. 5 times 6 is 30. 30 has a 0 as a last digit as this. Yes, so you can have that. And you cannot have 96 times 97, not even 98 times 99. You can have 99 times 100. When you multiply, you get 0 as the last digit. But if we say 90 times 91 is a smaller number than 9120, so strike off. 94 times 95 is also smaller than 9120, so strike off. 95 times 96, if we calculate, we get the answer as 9120, so yes. And of course 99 times 100 is not. Okay, so we have got two factors, 95 and 96. So let's solve for that. So we have two factors, x plus a times x minus b. So I'm going to write that x plus, you will have a bigger number 96 as a, and the smaller number 95, x minus 95. Why? Because b is less than a. So you have the two factors, what we have written here, x plus a and x minus b. Now this is how you have got the factors using the first method, the two values for x. Because it's a quadratic equation, there are two solutions. Now the other method, which is very, very wonderful and easy, second method. In this, you have this equation, x squared plus x equals to 9120. Yes, that's what we are solving. Here you can take out the greatest common factor, x, and you'll be left with x plus 1 inside, which is equal to 9120. And here 9120 can be broken down into the numbers 2 to the power of 5 times 3 times 5 times 19. If you take out LCM or using the ladder method, you can even break it down into this. Now if you see 2 to the power of 5 times 3 is 96, and 19 times 5 is 95. So 96 times 95, you get the factors easily. Now when you see the subtraction is 1 and the product is 9120 for this 96 times 95. So here x belongs to integers. It can also be negative, right? Yes. So you have, suppose x is 95, x plus 1 is 96. So you have 95 times 96. And now if x is negative, that is 96, negative 96. Negative 96 plus 1 is negative 95. Substitute. So you get two values for x. x1 is 95, x2 is negative 96. So here you have got x1 is equal to 95 and x2 is equal to negative 96. So you've got two integer solutions for this quadratic equation. So if at all you have any suggestions, you can write it in the comment box. Thank you so much for joining. Thank you so much for watching and making LK Logic as the best channel ever. Thank you so much for always supporting. Bye bye. Take care.